Hi guys, welcome to my channel, and this video is about recursion and what recursion is and how we can implement recursion in our program. So let's get started. So a function calling itself is called recursion. This is a basic definition of recursion. So let's see what does this mean. Let's say you have a function a, and here is the function body. So you call a from your function a's body. So when the thread comes here, it will again call a. Then again the thread comes here, then it will again call a. So this is basically recursion. A function is calling itself. So that is what recursion means. Take the most popular example like the factorial. So what is factorial? We know the factorial of 5 is what the factorial of 5 is 5 into 4 into 3 into 2 into 1. This is the factorial of 5. What is the factorial of 6? The factorial of 6 is equals is 6 into 5 into 4 into 3 into 2 into 1. So for 5 it will be 5 into 4 into 3 into 2 into 1. This is the factorial of 5. So we can see. So how we can write recursive solution of this factorial. So let's say your function factorial and you want to find the factorial of 5. So you write factorial in this function and this accepts your 5. So if you want 5, you will pass 5. So now, so what we can write like you can think of factorial of 5 as 5 into factorial of 4. And what you this factorial of 4 means, you can write it as 4 into factorial of 3. Then you can write factorial of 3 is what? 3 into factorial of 2. And what is factorial of 2? Factorial of 2 is 2 into factorial of 1. Now when you come to factorial of 1, you know what is the factorial of 1. It will be 1. In recursive, when you write recursive programs, you at least should know one answer to this question. Like if you're passing factorial of 5, you should at least know factorial of 1. Like you should have knowledge about one output of a function. Like if you pass 1, what will be the output 1? You should at least know this, because this will be your base case and this will be your terminating condition of your function. So let's say now what will write? I will write the base case after I write the return statement, because it will make you like you will understand it better. So what I will return from here, return n. Here n, if you pass 5 first, then it will be 5 into factorial of n minus 1. So let's take an example case. You have passed 5. So what you have passed 5. So the counter will come. Here will be 5 into when this 5 comes here, it will be 4. So factorial of 4 will be called. So from here you can see this will be called. Sorry, not this. This will be called 5 into factorial of 4. Again the program comes in here, and you can see that you can see that the 4 now n is equals to 4. So 4 will come here and factorial of 3. Now n is equals to 3. So n into factorial of n minus 1, 3 is equals to 2. So when it comes to 1, you have to like at least like this is a terminating condition, or else the function call will grow. Like if you know when a function is called, a stack is maintained. So what will be the stack here? First factorial of 5 is called, then factorial of 4, then factorial of 2, sorry, factorial of 3, then factorial of 2, then factorial of 1. So and in this case, you know the behavior of stack is last in first out, because fact which is called last will pop out first. So that you should at least know this value. What is output? So factor of 1 is 1. This goes out. So what will be this will be 1 into 2 into factorial of 1. So 1 by 1, this method calls will be popped out of the stack. So when factorial of 1 comes, the value of n here is equals to 1. So when this value of n becomes 1, you can write if n is equals to 1, return n. I think it makes sense. So this is what factorial means. Finding a factorial using recursive program means. Just a minute. Now let's understand a bit better what I did previously. So what we did was we were trying to find the factorial of 5. So what it will be? This will be 5 into factorial of 4. What this will be? 4 into factorial of 3. And what this will be? 3 into factorial of 2. Factorial of 2, what will be? 2 into factorial of 1. Here we can see we have hit the base case. So this will be 2 into 1. What is the answer? 2. So here it will 2. It will come 2. So what is 3 into 2? 6. So 6 will come here. 6 into 4, what is this? 24. 24 will come here. And 24 into 5 is equals to 120. Factorial of 5 is equals to 120. This is like you can see the first this function is popped, then this function is popped, then this function is popped, then this function is popped, and then this function is popped. This is how recursion works. Factorial of 2, you can see you have called it, you have got the value from here. Factorial of 2 is 2 into factorial of 2 minus 1. So factorial of 2 is 2. Factorial of 3, what it is? 3 into factorial of 2, 6. So this is how you can see this works. So you can see we are forming a tree-like structure in recursion. So when you have, you can see that you have only one recursive term in this function, which is fact of n minus one. So when you have only one recursive term, so it will produce a unary tree. So you can see this is a unary tree. So so let's now find out what is the time complexity. Time complexity. What is time complexity? As we have seen in the previous videos, it is like the number of times a particular statement is running. So you can see how many. Can you tell me, like you can guess from here how many times these statements are running? These statements are running how many times? So if you have n is equals to 5, so how many times it is running? Let's see. For this, is called first, second, third, fourth, and this one is fifth. So you can see that the time complexity is more or less equal to the value of n you pass here, 5. So here the time complexity will be O of n, because you can see that we have passed 5, so the algorithm is running 5 times. And not algorithm, like I mean the statement is running 5 times. So according to the definition, the time complexity will be O of n. Now let's see what is a recurrence relation. So every recursive program you write will have a recurrence relation. So what is recurrence relation? Writing a function with respect to its smaller version, mathematically writing a function with respect to its smaller version. This is called recurrence relation. So let's see the program we have written before for the factorial. It was fact of n. If n is equals to 1, return n, else return n into factorial of n minus 1. So what will be the recurrence relation of this recursive program? You should know that for every recursive program there is a recurrence relation. It is mandatory that every recursive program will have a recurrence relation. So let's see what will be the recurrence relation of this. So the recurrence relation of this will be fact n is equals to, what will be the value of fact n? The factorial of n will be 1 if n is equals to 1. Else it will be factorial of n minus 1 if n is greater than 1. This is the, I will write in a better way, so that it will be better for you to follow. Just a minute. So the recurrence relation will be fact of n will be 1 if n is equals to 1, or else it will be fact of n minus 1 if n is greater than 1. So here we can see we have removed the term n because it is constant. It is like defined as a constant here. So we have not taken it into account because it is a non-recursive term. Like here it will be n into fact of n minus 1. So we have not taken n because it is not a non-recursive term. And we can see that the definition of recurrence relation is writing a function with respect to its smaller version. Mathematically writing a function with respect to its smaller version. So we can see this is this, and this is this. So we are writing a bigger function with respect to a smaller function. So this is called recurrence relation. And I want to reiterate one thing, that every recursive program will have a recurrence relation like this.